Zawala again. In this video, we're going to be focusing on probability and statistics. We're going to be focusing actually on the permutation and combinations. That is the counting principle, the number of possible arrangements of n objects taken r at a time. The fundamental counting principle involves determining the number of possible arrangements. For example, we say the number of ways you can perform a task involving several parts, like 1, 2, 3, 4 parts or n parts, is given by the number of ways each part can be performed, by the product of the number of ways each part. So the total number of possible ways is given by the product of these different ways, where n1 represents the number of ways the first part can be performed, n2 represents the number of ways the second part can be performed, and so on. We present to you a real situation so that you can put this idea together. For example, here's a practical situation. We have 5 pens, 6 shirts, and 2 pairs of shoes. How many possible attires can you wear? So the 3 parts we have for this thing is the part involving pens, the part involving wearing the what? Shirt, and the task involved wearing the shoes. So how many possible pens could you possibly wear? 5. So there are 5 ways you could perform the task of wearing the pants. How many shirts do you have? 6. So there are 6 ways that particular task of wearing your pants will be performed. And you have 2 pairs of what? Shoes. So the total number of attires you could possibly wear would be 5 times 6, 30 times 2 would be what? 60. So this is a typical application of the counting principle, multiplication counting principle. So counting when order matters. Whenever we are dealing with operations involving counting the number of arrangement, when order matters and there's no repetition, we say that we have a combination. Okay? In a combination, order is of importance. Okay, but we're going to come back to that later. So let's look at some other concepts here. Let's talk about this concept first before we even get to that. So the number of ways to arrange n distinct objects, number of ways you can arrange n different objects, is given by the notation of n factorial. So what do we mean by factorial? Factorial is the value that you can compute by this. Say, for example, you start with n and you find the product by going down by 1, reducing n by 1 and so going all the way down to getting 3 to 2. So, for example, if I ask you to get 5 factorial, it is 5 times 5 minus 1, which is 4, times 4 minus 1, which is 3, times 3 minus 1, which is 2, times 2 minus 1. 5 times 4 is 20. 20 times 3 is 60, times 2 is 120. So 5 factorial is 120. All right? So that's why we say the number of ways you can arrange n distinct objects. So for example, if you have 6 objects, so that means the first slot could be occupied by 5 objects. The first slot could be occupied by any of the 5 objects. Now, so one slot has been taken, now you have 4 objects. So only 4 can occupy. So that's why you see we have that way of finding factorials. So now sometimes we have computations wherein we talk about some of the objects are localized or they are repeat. So in that case, the way we can compute them would be something like this. Normally on the WAEC, these kind of problems involve like words like Mississippi, banana. See, I'm looking at banana. So I have 6 letters over here. 6 letters here. So that means my n is 6. So we say 6 factorial. Now, basically, I have how many different letters here? 3, right? B, A, and N. 3. How many B's do we have? 1. So we say 1 factorial. How many A's do we have? We have, how many A's do we have here? 3 A's. So we say 3 what? Factorial. And then how many n do we have? We say 2 factorial. That's what this formula is talking about, and that's how we use it. So then we'll make the computation here, and we're going to do some problems where we're going to incorporate this idea. So now when we talk about the arrangements of objects, we want to consider whether the repetitions are allowed or repetitions are not allowed. When repetitions are not allowed, and the order makes a difference, the order is important. Say 1, 2, is different from 2, 1, then we say we have a permutation. So if I ask you how many different ways can we choose the president and the vice president from a group of 20? So that means the number of objects n is 20, for example, and I'm electing 2 positions. So R is going to be what? 2. So I'm basically asking you to find the number of permutations of turning objects taking 2 at a time. Now, order matters. It matters whether you are the president or the vice president. So in this case, order matters. We'll get into some problems. So this is how we compute it. We say n factorial divided by n minus 1 factorial, n minus r factorial. We're going to do problems and see how we can put that in. So then we talk about a situation of combination. There's a counting method where you are taking in, similar to what we did, but in this case, order doesn't matter. Usually, for problems involving combination, you're going to see words like committees or some kind of thing where the order doesn't make a significance. So this is how we compute it. The number of combinations that is possible of R object out of n is given by n factorial over n minus r factorial times r factorial. So note the difference between this formula and the formula for permutation. Well, this formula you're going to see is going to produce a fewer number, a lesser number, because, for example, in this thing we say order doesn't matter. So 1, 2 will be the same as what? 2, 1. So they wouldn't be counted as separate arrangement. They're the same. Sets formation would be something that is amenable to that. Then one of the last concepts that is seen in the WAEC, kind of found a problem kind of accurately placing, is the number of possible subsets. So the number of possible subsets of any set is given by what? 2 to the power of n, where n is the number of objects in the set. So if you had a set of, say, 2 numbers here, 1 and 2, how many possible subsets can you form? Well, the n here is what? 2. So you do 2 to the 2, and that will be what? 4. Let's see the subset that we can form from here. The number of possible subsets here will be the empty set. That's 1. Another set that just contains one element 1. Another set that contains the element just 2. And another set that contains both element 2. Now understand, 2, 1, 1, 2 are the same thing. So how many subsets do we have here? 1, 2, 3, 4. Again, the empty set and the universal set will be subset of the set. So now here's the first problem we have here. This is just kind of putting the factorial concept into use. This is taken from WAEC Liberia 2006. It's problem number 27. They said evaluate this expression when x is equal to 6 and y is equal to 3. So basically x is equal to 6. Let's do the first substitution. And then y is equal to what? 3. So I have 3 factorial squared. Now, watch what I'm going to do. This is mathematics. It can be creative. So I'm going to do 3 factorial times 3 factorial. Is this right? Yes. 3 factorial squared means 3 factorial times 3 factorial. So I will do this to minimize the chance of using calculator. So here's what I'm going to do. I'm going to write 6 factorial as 6 times 5 times 4 and 3 factorial. Now, why do I do so? You're going to see the reason for that shortly. So I'm going to write this as 6 times 5 times 4 times 3 factorial. And then down here I have 3 factorial, and this other factorial I'm going to expand it. 3 times 2 times 1. Now, the reason I did this is that this 3 factorial will cancel with this 3 factorial up here. So now I'm going to be left with what? 6 times 5 times 4. And at the bottom here, 3 times 2 is 6 times 1 is 6. I'll be having a 6 here, and this will cancel. And my answer here will just be what? 20. Okay? Very simple, very basic way of calculating it. Just have to show the level of creativity in the ways we did it. You could have gone ahead and multiplied the entire 6 factorial and do everything at the bottom. That, engage in the problem in the best way possible, but it will still give you the answer. So here's what I was talking about when we talk about lookalikes. So we have a word here. Find the number of permutation in this word. So in this word, the order matters because, when you change the info, you're talking about word. When you change, you can have 2 letters in a word, L-O and O-L. Those are 2 different words. So in this spelling words here, that doesn't matter. Now, good. But here we see here that we have how many letters do we have here? The number of letters we have here will be 1, 2, 3, 4, 5. 5 letters. In here, we see that for E's, the number of E's we have will be what? 2. The number of L's we have, how many L's do we have? The number of, so for L's, I'm getting a little bit. L's. The number of L's we have, how many L's do we have? 2, and the number of N's we have will be what? 1. So, we can use this formula that tells us that to do this, we have to do n factorial over 2 factorial because of the 2 E's, 2 factorial because of the 2 L's, and 1 factorial because of the 1 N. So we have 5 factorial, and again, I'm going to use this computation strategy. I want to cancel do some cancellation and minimize my computation. So I'll do 5 times 4 times 3 times 2 factorial. I will leave it like that. And 1 factorial is just going to be 1. So I'll do 2 factorial. And then 2 factorial here is just 2 times 1. Now, what happens here is this 2 factorial will cancel with this 2 factorial. I will have 5 times 4 is 20. 20 times 3 is 60. Then I will have 60 divided by what? 2. And that will give me what? 30. So the number of permutation in the word Ellen is going to be what? 30. So it says here, how many subsets are there in the set? So we already talked about this. So how many elements do we have in the set? 1, 2, 3, 4, 5. So n is equal to 5. The number of possible subsets is always given by 2 to the n. That means 2 to the 5th, which will be equal to what? 32. So the number of possible subsets here will be what? 32. Okay. So it says here, in how many different ways can a committee of 6? Now, usually when you talk about committee, think about combination, not permutation. Because committee, the arrangement is insignificant. So, you're forming a committee of what? 6. Alright? Now, how is this committee going to be formed? Choosing from 4 girls, and 5 boys. If 2 of the committee members must be girls, so the first 2 slots are given to girls, so you say 4C what? 2. So this will give you the number of ways you can choose girls. So the total number of combination will be the number of ways you can choose girls times the number of ways you can choose the boys. How many boys are you choosing from? 5. And how many members are supposed to be in this committee? 6. You're already taking 2 to be girls. So the remaining 4 will have to be boys. Okay? So then we must compute these things. So let's do some computation here. Let's compute 4C2. Well, this is combination. The formula for combination says 4 factorial over 4 minus 2 factorial times 2 factorial. So 4 factorial would be 4 times 3 times 2 factorial. I'm going to leave it like that. And then down here, 4 minus 2, that's going to be 2 factorial. And there's another 2 factorial down here. So what's going to happen over here is that 2 factorial is going to cancel with 2 factorial. 4 times 3 is 12. I will have 12 divided by 2. So the number arrangement for the girls will be what? 6. So let's do the one for the boys. So for boys, I'm computing what? 5C what? 4. So I have 5 factorial over 5 minus 4 factorial times 4 factorial. So what I'm going to get here, I'm going to bring it over here. 5 factorial, I'm going to do 5 times 4 factorial over 5 minus 4 is 1. I have 1 factorial, 4 factorial. Now these 4 factorial will cancel, and I will be left with just what? 5, because 5 divided by 1 will be 5. So the number of ways you can choose for that will be 5. So now I have 6 times 5, and then my answer will give me what? 30. So there will be 30 different ways that you can form this committee. It says how many different 6-digit license plates can be made if the first digit must not be a 0 and no digits may be repeated. So let's do something. So what are the digits we are talking about? We are talking about the number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Digit 1. So, well, how many do we have altogether? 9 minus 0 is 9 plus 1 is 10. So we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see. Let's fill up the slot. First digit, second, third, fourth, fifth, and sixth. So the first digit cannot be a 0. So you take off 0, you'll be left with 9 options. So the first slot could be occupied by any of the 9 numbers. Now, the second could be any one of these. But understand that one of them are already been taken out. So how many options do we have left? 9. 9. It could be 0. So that's 9. Now, next one. So 2 slots have already been taken out. So that means you are taking out 2 digits already from here. So how many digits do you have left? 8. So this part will be occupied by any of those 8, then 7, then 6, and then 5. So you find the product here, 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 here. Now let's go back. Why do we have 9 in the first place? Because we do not use a 0. So we are left with 9 options. Why do we have 9 here? Because even though we have 10 numbers, 10 digits, one has already been taken. So now we are only left with 9 possible ones to fill up that spot. Why do we have 8 here? Because 2 have been taken out, so we are left with only 8 possibilities, and so on. So we can find the product here, and the product here will be 136,080. 136,080 different license plates can be made. How many 3-member subsets can be formed from this below? Good. Well, these are some of the problems wherein you see and you wonder what's going on. But yeah, one thing, you are forming a set. A set is just a collection of objects. In a set, if I have a set, say, if I change the order of the elements in the set, or have I changed the set? No. The arrangement in the set is the order is insignificant. So a problem like this, we have to use what? Combination. So what are we doing in combination? How many elements do we have here? 1, 2, 3, 4, 5, 6, 7. So we have 7, and we want to choose how many? 3. 7, C3. So how do we do the combination formula? It's given by what? 7 factorial over 7 minus 3 factorial times 3 factorial. This gives us 7 factorial over 4 factorial and 3 factorial. And this will give me 7 times 6 times 5 times 4 factorial over 4 factorial and 3 times 2 times 1, because I'm doing the 3 factorial. Now, 4 factorial here will cancel with 4 factorial here, and 3 times 2 times 1 is going to be what? 6. 7 times 6 times 5 is up there. The 6 will cancel, so my result will just be what? 35. So we can form 35 3-member subsets of these sets we have here. Okay? Again, it's combination because the order in which you form, the order in which the elements are arranged in the set is insignificant. So the last problem again is something that we did it before. I just thought about bringing this. I saw this on the WAEC for 2010 Liberia, and because it says Salala, and I grew up somewhere around Salala area also, I said, well, let me take a problem like this and do it and put it on the screen. So, well, again, we're talking about permutation, so we know the formula of permutation. But here, we have some localized repeats. We have, for example, S here, we have one S, A, 1, 2, 3. A's, we have what? 3, and then L, we have what? 2. So A's are we have 3 A's, so we call that localized or repeat, and 2 L's. So, our total number we have here, the number of elements we have here would be basically what? 6, right? 1, 2, 6. So we say 6 factorial, let me do that right here. 6 factorial over 3 factorial, 2 factorial. And it's kind of insignificant to write with 1 factorial, so I'm not even going to write that down. I'm not even going to put the 1 factorial down. So let's do that. Does it make a difference? So what do we have here? Again, we use simple computation, 6, 5, 4, and I will stop at 3 factorial because I see a 3 factorial down there I can cancel that way, and then I'll do 2 times 1. So that will cancel. I will have 6 times 5, that's 30 times 4, that's what, 120. 120, 2 times 1 is 2, and then I will have what? 60 different permutations here. So again, thank you. This has been a production of the Foundation for Equity and Excellence in Education in Liberia. A foundation dedicated to providing quality content education, instructional materials across all content areas. Please support our cause. You can visit us online at www.freeliberia.org. And whilst we are there, please don't forget to make a contribution. Follow us on Twitter, like us on Facebook. Don't forget to subscribe to our YouTube channel. Thank you very much.